Hello everyone, welcome to day 6 of the challenge. So let's continue where we have left from yesterday. Let's open our terminal and let's set our timer to 60 minutes. We have completed 1 star to 2 star, the available modules, and we are now solving from 2 star to 3 star. Let's open time complexity. And we were solving n pairs question yesterday. Let's open this. Let's open autumn. Before that we need to change the directory. Autumn n pairs. Here is where we have left over yesterday. The problem with our code is it is running, but we are getting an TLA. Let's close these files here. We are facing TLA, time limit exceeded, while running few test cases. So here we are implementing equal number of operations that we will implement even if we are using 2 for loops. Though it looks like we are implementing one loop, this if block is making and maintaining another variable is the reason for us we are able to make it run like 2 for loops. So we are doing same number of operations. Now we need to think of a way where we can reduce the number of operations. By the way, if you want to see how we reached to this point, you can see the before video, which is day number 5. So we are not thinking of a way to reduce the number of operations. Well, maybe we are missing something from the question. So let's read the question one more time. Here it says get a string s. Okay, it's saying to read. It is saying to read numbers or numeric characters. Okay, we are reading and we are printing if it's a nice pair, if the difference between the numbers and the difference between its positions is by the way, all this is an explanation. Positions is equal, then it's a nice pair. We'll get the test cases, we'll get a number 9, we'll get a string of length n. Those things will contain numeric characters 0 to 9. For each test case, output a single integer. And here are the constraints. Can we use a map for this question? A map where we can store the differences. I don't think we can use a map, or can we use a map? I think to reduce the number of operations, let's say if the array size is 942412 34. Okay, here the maximum number is always 9 and the minimum number is always 0. Okay, these are the indexes. Let's say 0. That means that the maximum difference can be 9 here and here. Okay, and the minimum. Okay, how then what if the maximum difference is 9? So let's take one more element, 4, and let's say its index is 9. Okay, 4 is already taken few times. Okay, no problem. Let's take 8 and let's say its index is 10. Since for these numbers the if you choose any two numbers, its maximum difference is 9. That means for the indexes to have the maximum difference 9, you can choose subsets of 9. That means for every for loop, the inner for loop need to run only 9 times instead of running it till n, right? Like it need not run from 0 to 10. If it only runs from 0 to 9, it's enough. I hope you got the point, right? Let me explain. If you take 9 here, and if you check with 4, the maximum difference is 5. These are not 5. And 9 and 2, maximum difference 7. 9 and 4, maximum difference 5. 9 and 1, maximum difference 8. So if you choose 9 and let's say any other number, let's say 0 here, let's say this to 1, 2, and let's keep here 0. So for 9 and for 0, to get the maximum difference, you can only choose these numbers. If 0 is somewhere in between, it doesn't work, because for the strings, for the indices, its position should be, we cannot get the maximum difference 9 for the indexes if it is between the 9. So I'm saying, if you choose this element, you need not search for till end. You can only search for till first 9 elements itself. That way we are reducing the operations from 12 to 9 itself. Okay, from 10 to 9. 10 plus 1 level to 9. That means we have reduced 3 operations. But here it's saying like 10 to the power 5, right? So it's like 9 and 10 to the power 5. It's like you have saved a lot of operations. It's almost 1 into 10 to the power 4 plus 1 operations you have saved for every for loop. That means inner loop should be not be equal. Okay, that means j can run n times. We will put j here, and we are changing I, right, for every time we are running it. So I is moving from here to here to here until to n. I need not move to n, it can move till 9. That's a very small change for our code to work out. So let's paste here. Let's submit. Okay, before that, let's compile ours. We haven't changed anything. We have changed only one thing. 3 to 9. Yeah. For this sample test case, we are getting correct output. We still got runtime error. I didn't get any runtime error. Copy this. Control A, Control C. Perhaps we didn't copy it properly. These comments are not necessary. Cancel. I pressed Control S out of habit. Let's leave them here, no problem. We still got some runtime error. I'm not getting any runtime error. Actually, even this we need not convert into those integers. We can just say a of I minus a of j, because those things are strings, and you will automatically get the differences because it's starting from 49, right? So if 1 minus 2, it is 1, 49 minus 50 is 1, so you may not convert it actually. Let's compile it. Yeah, we didn't get an error. Let's copy and let's paste. Yeah, this is working. What about this? Submission code running test case 2. Yeah, I guess to the test case 3 is okay. We got runtime error one more time. 6seg. I have no idea what is 6seg. 6seg. Okay, I have searched it, multiple times. Segmentation fault. In C++, occurs when the program tries to write /read outside the memory allocated for it, or when writing memory which can only be read. In other words, when the program tries to access the memory to which it doesn't have access to. Okay. We are trying to access some. Okay, and let's say I is less than n, because when we are doing I equal to j plus 1, when I equal to is 9, let's say j is less than n. Is our I going out of the border? Okay, let's just run it. I was trying to run it in my brain, so I'll just speak out what I was going in my brain. So initially j will be 0 and I will be 1. So you will compare the first element and the second element. Then j will be, then I will go for the second element, then it will go for third element, fourth, fifth, sixth, seventh, eighth element, then it will go to the ninth element. That means from here to here, when it goes to the ninth element, then we'll increase the j and we'll say I equal to j plus 1, then we'll get back I here. So there is no scenario where I is not equal to j. I is equal to j. Or is there any scenario? I guess this part is not necessary because our I and j are never getting collided before it's n. So now j is here, I is here now. Now 1, 2, 3, 4, 5, 6, 7, 8, and j will go on increasing. Here there is no ninth element. So what should we do there? If there is no ninth element, and let's say or, okay, we cannot say or because I will be always less than n. We need to enter into this if statement. Or just shall we just say j plus 5, j plus 9, and okay, we cannot do in that way also. The problem here is I is just going on increasing. It is trying to reach this place when j is equals to 1 or j equal to 2. So if we try to increase it and we are trying to increase it and we are coming here, okay, we'll just say equal to 9 or I is greater than n, greater than or equal to n. If it is equal, we need to reset it. No, we need not reset. If it is greater than n itself, we need to reset it. So I guess now we will not get the error. Let's just submit it. Before that I need to check it once. in my time. Actually, first I need to check it, then I need to click on submit. What I do? Okay, I'm getting wrong answer. I guess I and j should not be equal to, because it is counting twice again. Control C, G++, n pairs. Three, 2, 9. Yes, it's working properly. Oh, sorry. I didn't mean to click on it. Okay, now let's submit it. Okay, I thought I and j will never be equal. How are they equal? J is 0, I is 1. J will be 0 itself. So I will start from 1, 2, 3, 4, 5, 6, 7, 8, 9. Next, if it is going greater, we still got wrong answer. This is wrong answer and this is TLE. Okay, what is our mistake here? If I is at the 10th place, we cannot reset it. We need to compare, because maybe in the 10th place we got the solution we need. A 10th index. Well, what is the mistake we are doing? Let's just reset our code. Let's not disturb anything that we have the code we got from yesterday. Let's just get back to it. I thought it's not necessary. Let's just change this, and the problem of changing it is it's going out of the bound, out of the limit. Let's copy, let's paste here. Before that, let's just run our one time in our terminal to check there are no compilation errors. Yeah, everything is working fine for small values. What about the larger values? I don't want to disturb any part of this code. We are just changing them into pure numbers, and then still we got the wrong answer. This thing is correct. This is WA and this is TLE. We are reaching time limit exceeded. Still we are reaching time limit exceeded. Let's just remove all this thing, and let's just take one for loop. Let's say the equal to 0, I less than n, I plus plus, and let's take another for loop, j equal to I. Okay, we are j equal to I. Where is I? From there we are starting, right? Okay, let's just go here. Let's just comment our logic first. Our first logic. Let's just create another variable count, which is common actually. Okay. Why not? Let's just uncomment this thing. No problem with the I and j values, because in the for loop we'll reinitialize them. plus plus 5 int j equal to 1. J should be less than or equal to I plus. Okay, we need to start j from I plus 1, I guess, because that's what we are doing before. And less than 9 I plus plus, it should be less than 9, and j should be less than n also, both the conditions, or else we'll reach we'll go out of the range and we'll get segmentation fault, accessing the memory locations that we are not supposed to access, or that we didn't use also. I will say if a of phi minus a of j is equal to I minus j, then just increase the count. Simple. Cool, let's copy. Okay, segmentation for core dumped. Why are we giving 5 8? Why did we read it twice? Clear. Okay, our half an hour is wasted. It's not wasted, we are just trying to, but we are taking a lot of time. Let's just copy, Ctrl Shift V. What the hell is happening? The input is 3 3 1 2 3. Here itself we got segmentation fault. Let's just remove I and j from here. What is okay? We are also reading n. N is nothing but 3, right? What is A? A is our string. Count is the variable we have created. Now let's compile and let's run. Still we got segmentation fault. Code dumped. You can't use this in this way. Okay, it's not I plus plus, it's j plus plus. We are increasing I twice. Yeah, it's correct. 1 3 4 9 2. It is also, it's wrong actually. Next we have 8 9 4 2 4 1 2 3 4. We got 6. Okay, we got wrong answers actually. 3 1 6. What are the right answers then? Here we are just converting here. We need not convert. Okay, let's take absolute values then. Maybe that is the mistake, because yeah, we will always get negative, right? Always get negative here for indexes. Yes, I is in the starting and j is in the ending, so I'm guessing that's the problem. And paste, and let's run our 5 1 3 4 9 2. Okay, 5 and 5 1 3 4 9 2. We got 2. Yeah, it worked properly. Next 8 9 4 2 4 1 2 3 4 6. What is wrong here again? What's wrong with our code? Okay, this should not run for the I times, it should run for I plus 9 times. Copy and paste. 3 to 9, yeah, it's running properly. And let's just paste here. Submit. That was actually pretty easy question. We need to just run it 9 times. What is the mistake here? We still got the wrong answer. Wrong answer because should it be equal to? Should it be okay? We need to check that element also, right? We need to check for that element also. So let's copy all this. Let's just paste here. Let's just submit. That's what I was explaining, right? If I is at the end in this question, equal to 9. If it's at the end also, now it's correct. Actually, it's pretty simple. Using 2 for loops, but you need to make it till only 9. But I have tried to get smarter and went for the single while loop and got myself confused. Anyways, let's just go to the next question. And actually we were solving 2 questions every day and we still have half an hour. Let's just close this and let's just say autumn cake walk. Let's hope solving this will also be a cakewalk. And now we are having, okay, we should name it like that. We will name with the problem code ck.wlk.cpp. So we need to close this, don't save, and let's open ckw.lk.cpp. In that way it will be quite easier for us to access the codes. You are playing EV online. Initially you have $1, but you have somehow acquired 2 cheat codes. The first cheat code multiplies the amount of money you earn by 10, while the second one multiplies it by 20. The cheat codes can be used any number of times. You want to have exactly $n. Now you are wondering, can you achieve that by only using some sequence of cheat codes? Okay, this is also a string. The first line of the input contains a single integer t denoting the number of test cases. The first and only line of each test case contains a single integer n. For each test case, print a single line containing the single integer s if you can make exactly $n or no otherwise. Okay, I didn't understand it at all. You have $1. Okay, I have $1. But you somehow acquired 2 cheat codes. The cheat codes can be used any number of times. You have to you want to have exactly $n. Okay, I want to have $200. What is EVG game? Is I guess this is not the game. Okay, let's just code it ourselves instead of using the snippet. We need to read the test cases. Let's just solve it here. We need not have solve a function separately. and let's say int, and we are reading n. We got 90. So it's basically if n is divisible by 20, and n is divided by 10, you can achieve it by using those operations, or multiplying a number of times. Else out, no, since the output is case sensitive. Okay, I thought it's not case sensitive. No, that's it. Here it is no. One zero two four. Okay, we need to avoid all the zeros here. Twenty and 10. 20 to 20 to 20. You cannot get 1024, right? Is it a string? Integer n. Now we need to find a way to remove the zeros. Let's just run our Python 3 in the terminal. Excuse me. And we have 1024, 123, and few number of zeros here. If you divide it by 10, it is perfectly divisible. But 1024 you cannot get. How do you solve this? You need to take only first numbers. You can remove all this using a loop, but again, the point is you may get TLU. There must be a way where you can solve this in exactly in order of 1. Is it anything related to bits? Because then you can represent as 1 2 power 4 2 power 3 is 8, right? So 0 0 0, and you need 1 2, so this is 10. 1 0 1 0 and 20. 2 power 4 is 16, so 1 0, and 2 square is 1, so this is 20. If two numbers are divisible, then their bit will be like, let's say 1 0 and we have 100, and if we do AND of them, we'll get 0, so they are divisible. If we do AND of them, we'll get 0. So let's just use AND operation. Bitwise, I forgot the bitwise AND symbol. Bitwise and in C++. It is a single AND. So let's just say if n bitwise of 20, if you are getting 0, we should use not of n and 20 and not of n and 10. I guess that's it. Let's just compile, copy all this, paste all this. We got no. For everything it's no. It is something related to bits. Why do I feel like it is something related to bits? Excuse me. We still have 23 minutes to solve this. Should I use this loops and perform less number of operations than required? What should I do? I'm thinking of an idea where let's just remove this knot and let's just see whether all the given numbers are divisible by 20 or not. We are running it already. 200 is divisible. Yeah, okay. 200 is not divisible. Why are we having a jump here? Did I write ender anywhere? Let's run it and queue manually. For 200 it's saying no. So it's not bits. Let's take the solve function. And this time the number is 10 power 18, so we need to take a long. So hash define ll as long and LL. What am I thinking? I'm thinking, should I use, can I use recursion or can I use two while loops to solve this? In recursion, we can call the number and divide it by 10, but we are having two separate calls for 10 and 20. Shall we have two separate calls, or can we return I don't think using recursion is good or proper. I think let's just go with the classical for loops. Let's just say while sorry for my voice, excuse me. So we are taking everything as long. We need to read the int, right? Okay, LL n. See, in n we are reading the n and we are saying we'll go on while if n is divisible by 10, if n is divisible by 10, then we'll just remove all the zeros from it. And if n is not divisible, all the zeros from it until we reach a point until n equal to 1. If n equal to 1, then this thing will stop. Or n equal to 1024. Yeah, it will stop. But now n is just 1024. And and while that's it, we are removing all the zeros. Can we write if now n divided by 2 equal to 0 and now n divided by 1 not 10. The point is, for this value then we'll go till 1, and for this n will go till 1024. So if we write n divided by 1, then every number is divided by 1. So let's just multiply it one more time with 10, so that it will remain till here. But for here it will again get one more 0, so it will be divisible by 10. So how do we do this? So let's just remove this thing here. Let's just check if n equal to 1. If n is a single digit, if it is a single digit number, then it is divisible by 10. Okay, or we can just write a long if else if statement. If n equal to 1, or n equal to 2, or n equal to 3, or let's just copy, Control C, Control V. Okay, we need those, or for 3, 6, and we need to go for 9, and one more time, n equal to only 9, right? So 9, 8, 7, 6, 5, 4, 3, 2, 1, until we reach a single digit. What if 16? Is 16 divisible by 20? But 160 is divisible by 20. What if we get 160? Then the output will be 16, which is a 2-digit number. Let's just say if it is a single digit number, and in that if it is an odd number, even number, we'll just print. In that way we'll be clearing one of the test case, few of the test cases. If n is divided by 2 equal to 0, then cout yes, and just return. But we need to write multiple return multiple couts. Now let's think about what if it's a 2-digit number, or 3-digit number, or in this case 4-digit number. One 0 2 4. Again, with the help of 2 and 1, you can never reach any number which is 1 2, like 1 2 3. Okay, the amount of money you won by 10. What if we won 1024? Why is he saying no? Can you only win $1? Two cheat codes. The first cheat code multiplies the amount of money you won by 10, while the second one multiplies it by 20. The cheat codes can be used any number of times. You want to have exactly, and okay, I understand 90 because 9 is something which you cannot obtain by multiplying 2 with any number. And what if we obtain and only by multiplying with 10? It may be possible, right? He may obtain it only by multiplying. So I actually don't understand. I'm not understanding the question itself. He's saying 1024 cannot be achieved by using any sequence of cheat codes. If you are starting from 1, then you cannot achieve it. Okay, let's assume we are starting from 1, then this is not necessary, and this is also not necessary. we'll have only even numbers, and 8 and 9, all these numbers are gone. Now if I'll compile it, it's CKWLK. What is this? Okay, you cannot have semicolon. Copy the sample input. You got yes. What about the other test cases? We'll just say no. Yes, no, no, no. 1. Okay, even if it is 1, we can say we can get it. What if it is a single one? It can be a single dollar also. We are still getting yes because 1 is not divisible by 2. Okay, fine, 1 is not divisible by 2. That's the reason we are not getting. We'll try for 5 more, 2 more minutes, and if we can't get the answer, we'll check the solution. What are we doing here? We are couldn't think of anything anyway. It seemed pretty. It's really funny that such a pretty simple small question is hard to solve. Okay, let's forget about really for a few minutes and let's just try to solve it without really itself. Let's say we have freedom to use as many loops as we need. We just need to get to the solution. In that way, we also we'll just take the number and we all go on dividing it by 20 and 10. If it is divisible, we'll remove the 0 and we'll check one more time. So we'll have the loop those many times. The moment it exits the loop, then we'll check whether n equal to 1 or not. If n equal to 1, then we'll say okay, for any number that is below 20 also it will exit like 19, 18, 17, 16, 15, 14 and 10. Okay, let's try it. While n divisible by 20 and n is divisible by 10, we'll just reduce that. And if n is 1, what if n is 0? It will not happen, right? If n equal to 1, what if n is 160 as we thought, or 16? Let's just check solution. Let's check Sumituma answer. Let's read. We have to check that how many zeros are in last, because ultimately we have to reach the number by multiplying by 10 or 20. So for this we have to check that whether the number is power of 2 or not, and if it is power of 2, then we have to find how much power it is of 2 is greater of 2. If greater than number of zeros, then again answer will be not possible. Okay, I got it. If it is, let's say, if the x, let's say the number 1024 is power of 2, log of 102, what is log of 1024 by log of 2? It is 10. But if the zeros are not 10, then it's not possible, because 2 power 10, 20 power 10, you will get 10 zeros automatically. So is it what they are doing? They're counting number of tens. If built-in pop count of n is not equal to 1, what is built-in pop count? Okay, I'm learning a new function today. Let's see. This function only takes unsigned or positive integers as a parameter. If n equal to 4, binary value of 4 is 100 and you will get 1. Somehow, see, it is related to bits. Okay, if n equal to, let's write it. If n is equals to 4 to 1 and run code. Dot request compiling. You got 5. 4 to 1, 5. Built-in of this function is used to count the number of set bits in an unsigned integer. Okay, number of set bits, the number of bits that are set to 1, right? Then it will count the number. If it is not equal to 1, then we'll print no. Okay, only one bit should be set bit. Okay, now because it's in 2 powers, right? Else, if it is not, then you will check whether it's divisible and you will divide it by 2. Go on, divide it by 2 and you will reduce the cn minus minus. If count is greater than or equal to 0 and n equal to 1, count is yes, else count. Okay, now it makes sense to me. Basically, you are assuming the number is in terms of basically the number is in the powers of 2, right? So you will count how many times the number is in powers of 2. So while we'll count the number of zeros, n percentage divided by 10 equal to 0, and we'll reduce it and we'll just increase the count. We got number of counts. Okay, we got the zeros count. Next we need to take the set bits, and next we need to count the number of 2's. Okay, So they are doing, okay, the timer is finished. We'll just set an extra 10 minutes timer. Dot slash timer 10. Yeah, now we have set the timer. Let's open auto, and now we have set. Okay, now we have got our number of zeros, and we'll check the number of okay, we'll use built-in bit. We got our number of zeros in the function. If the number of zeros is less than the number of powers, okay, there is an if, then there is an else, in which while n divided by 2 equal to 0, we'll just divide n 2 by n. So at the end of the day, if and count, and we'll also reduce count, because for every 0, let's assume for every 0 we got it because of 20 is powers, right? So if 20 power 8, we need to have 8 zeros, so we are reducing the zeros. If there are 10 zeros, the extra 2 zeros are because of multiplying with 10. So let's reduce the count also. If count is greater than or equal to greater than 0 or equal to 0 also, no problem, because now we have zeros more than, and n equal to 1 at this point, and n equal to 1, because we have divided by all zeros, we have removed all the zeros. Then 1024, now 1024 will go on dividing by 2. Okay, because here 1 2 3 4 5 6 4 5, there are only 9 zeros, but you have needed to have 10 zeros, so that's why we got no for it. In this condition, let's just say C out. Nice, this question is really good. We are using bit, what was that function name? Built-in pop count. Built-in pop count, to check whether the how much it returns number of bits that are set. Now see out, let's just say, okay, we need to say no right here, and here we need to say yes. Let's just compile it before we submit it, because we may have gone wrong somewhere, just like here. This is the end of else loop, so we need to have the end for the solve also. L value required as left operand of a sign in void solve in line number 21. If count is greater than or equal to 0 and n equal to 1, we are not setting there, we are just compiling, we are just comparing. No, yes, no, yes, and what about the last solution? Yes, no, and yes. This else pass will be executed, and if n equal to 1, I guess we need to write even if it is else, if n is not equal, if only one bit is set, and then count should be greater than 0, else see out as no. Yes, no, yes, no. Let's just submit it. I'm checking whether we're having no here also. Yeah, we have no here. Yes, the answer is of course correct. Let's just stop our timer. We have solved our 2 questions for today. We'll remove our error out because it is because of compilation. In pairs, we have started it yesterday and solved it today. And cakewalk also we have solved it today. Not bad. I have learned have new function, built-in function for this, built-in pop count. That's it for today. Thank you.